What we're going to look at today is we're going to go over pressure again for you, so you've got a bit of the knowledge there required. Ultimately, what I want you to do is, from what I'm about to go over here, is to each create your own explanation on how hydraulic brakes work, so the brakes that are in cars and some trucks, and why having a split in the line, in the brake line, is bad. Not to do with the brake fluid leaking out, but to do with the fact that air gets in. Normally those little cracks are so thin that the liquid doesn't get out, but air does get in. And I've got a little demo to show you that. But before we start with that, just quickly remind you what pressure is. Pressure is the force applied over a given area. So, if I've got a system, what we call a closed system like this one here, where I've got no air in there, these two syringes are filled with water, the pressure inside there is constant. If I apply a force here, the pressure inside doesn't change. But because of the pressure, it then applies a force on this syringe here. Alright, so if I was to push with the same force on both of these, the pressure, the different surface areas are going to make it feel different. Alright, so if I push with the same force, then actually this one normally wins out because the pressure inside is the same. We'll get to why that works in a minute. Okay, so if it's a force over a given area, you would expect the unit to be newtons per square metre. And that is one of the units for pressure, but we call it a Pascal. Alright? Bad joke that goes with this one is that Einstein and Pascal and, let's say, Newton, it doesn't actually matter, are playing hide and seek. And Einstein's one who has to do the seeking, so he closes his eyes and starts counting down from 10. And Newton and Pascal have to hide. Pascal runs away and finds somewhere to hide, and Newton just gets a bit of chalk out and draws a square on the ground and steps in it. And Einstein opens his eyes and goes, "Newton, what are you doing? You meant to hide." "Oh no, you haven't found Newton, you've found Pascal, because I'm a Newton in a square metre." Bad joke, I know, but we'll carry on. Okay, so you're now going to remember what a Pascal is, aren't you? It's a Newton per square metre. Right, so how does this work in the real world? Well, yesterday you looked at how change in pressure would mean that the force changes, which made the tanker collapse, because the force on the outside is bigger than the force on the inside, because we'd change the air pressure inside, but not change the outside. So over that area, there's more force pushing in than there was pushing out. It overcame the strength of the tanker and it collapsed. We also use it for more constructive things than destroying stuff, like how our brakes work on our car. In our car, we need to stop a 1 tonne mass that is moving at quite a high speed. So there's a lot of momentum. Therefore, a lot of forces are required in a very short period of time to stop a car moving. So you need to be able to apply your force of a foot, even if you're an old man or an old lady with not much force in your foot. You need to be able to apply a small force to stop a large object. This is done in a couple of ways. One is the fact that, of course, when you push down on the pedal, there's normally 4 brakes that apply on the wheels, so they all get stopped at the same time. So that helps you, magnifying your force. All right? But the real way that it works is very similar to this, and it uses this idea of pressure. This is my little model of a simple brake system. Here's your foot pedal, and here is the brake. So when this moves out, it touches the brake, it makes the brake disc move, and so it'll stop that wheel. Alright? And I can make it move with not much force, so I'm just going to move this to make it better. Okay? So, if we have a look at this side here, I'm going to apply just one finger's pressure on here and see that it's really easy to move. Alright? But if you see how far each of them move, you'll see there's a trade-off. So if we look at the 2 syringes here, I push down with only a little force, and this moves a long way, this one only moves a little way. And that's because the diameter, so therefore, when I do my calculation, the surface area of these is different. That small force that I apply there over a small area, okay, is creating a certain amount of pressure, but the pressure inside the system doesn't change. So that pressure must then be applied here. Well, that's got quite a large area. So if pressure is the same, but area is bigger, then the force must be bigger. So if I was to get someone to push against me on here, actually I'm going to do it the other way around. I'm going to push against someone else who just has to push with one finger here. Who would like to go at that? Cool? Okay? So you're just going to push with one thumb and I'm going to try and push against you with my whole hand. Go. Right, I cannot stop you. You are winning this so easily and I've got my whole hand. That's how the brakes work. With a small force, just your foot pushing down, you create a larger force because the pressure inside there stays the same. So my challenge to you is, use the system to explain why if there was gas in the line, that doesn't work so well. We're going to go again, Jaden, but this time, hopefully, it'll be a bit harder for you to push against me. Alright? Now, you're able to move the brake quite well, weren't you? The pedal, as it were, our model pedal was able to move quite easily, but it didn't move me at all. And the reason for that is to do with the air inside there and the nature of the particles in the two fluids. Gases and liquids are both fluids, but they have different properties. You have to use those two ideas to explain, one, how brakes work in a car. Number two, why getting gas in the line is a problem, which means that you have to bleed the line and refill it. Alright, so there we go. That's today's challenge.